Now, greetings, fellow grade 12s. It is still Mr. Shajor here. This is part two of our inverse functions, right? And now we are going to be looking at, our parabola function, where we are going to check the parabola function and also its inverse, right? Please ensure that you've watched the part one of this particular video so that you can have, much more deep understanding in terms of what is it that we are going to be discussing now, right? So now, remember, previously we've discussed that now inverse is just the word, it's just the normal word which represents the what, which means opposite, right? So this, it means opposite of something, right? So when we say inverse, now we are saying this is opposite of something, right? Now, so we are saying now, for an example, just like our parabola function, we know that our parabola function, it is given by y is equals to what? X squared. Are we fine, right? And just like what we discussed previously, now we are saying now this, right, this particular function also consists of its own inverse. And we said now, how do we find an inverse from this particular function, right? So we said, remember, an inverse, it's where where you switch your x to be your y and also where your y to be your x. We fine, right? So which means now, for an example, if you want, an inverse of this particular function, this will be the same as what? Let's say now this is going to be same as x is equals to y squared, right? And then after that, we would want to make this to be our subject of the formula, right? So which means this will be y is equals to the same as what? As root of x. Are it again, right? So basically now that will be the function of this, right? And now, how do we know this, right? How can I note this, right? Let's say now I want to draw this, whatever that I've just drawn, right? Whatever that I've just drawn now, whatever that I've just done in here, I want to draw this because there is some underlying concept which I want to explain to you with this particular graph, right? Number one, so we know that this is going to be our original, this will be our original inverse function, right? And if this is our original inverse function, right? Our original function, this, it is what we know that, our parabola function goes something like this, right? This is a smooth curve where it goes something like this and it comes back upward like this. Oh, it's okay, right? And now, right? And now, what is it then that I would do now? If let's say I would say I want you to draw a function of what? Of y is equals to your cube root of x, right? Now this would be a function that would look something like this, right? This would be a function that will look something like this, where now let me just draw it here. It's going to be something that is like this, right? So an inverse of this is something that is almost like this, all right? This is something that is almost like this, which is going to be the inverse of this particular function, right? But now I want you to understand this. I want you to understand this thoroughly, right? Now, when it comes to, our parabolic function, now here, this, right? This now cannot be identified as a function, right? Now, which means now if we have x squared, right? We need to have some form of restriction if you want to write it, if you want to write their inverse so that they can be a function, right? Firstly, why am I saying this won't be a function? Number one, for a function to be a function, we are saying it must what? It must obey the vertical test line, right? So which means now, for an example, if I can bring my vertical test line here, right? A vertical test line, it's just a straight line like this, right? Now, can you see that now here? I am having what? For each and every value of x, can you see that I am having how many values of y here? I am having two values of y, right? So according to then our vertical test line, right? According to our vertical test line, this won't be a function, right? This won't be a function, right? So whatever that I've just thrown in here won't be a function because it doesn't obey the vertical test line, right? Because can you see that for each and every x value, you are having what? 2y value, which is incorrect from here, right? So which means now, what is it then that we can do for this to be a function, right? So now I want you then to understand this underlying concept. Now, we are saying for our parabola function to be its inverse to be a function, it must have some form of restriction, right? Now, for an example, let me show you something like this, right? Now, let's say you are having this. Now, it's either the f of x squared, or rather, the f of x is going to be same as what? This is going to be same as x is equals to x squared, right? Now, it's either it's going to have a restriction where we are saying x can either be greater or equals to 0, or you are going to have an f of x where x, you are having x squared, where you're having what? Where you are having x, and then this is going to be where you are having your x as less or equals to 0, right? So this will be now either of these conditions that will make the inverse function to be what? To be a function, right? Maybe let's start with the first one, right? Maybe let's start with the first one. Now, so if let's say we are saying now we are looking for the inverse of function where we are having f of x is equals to, this is x squared, right? Where x is greater or equals to 0. Now, how are we drawing this, right? Now, this now can be what? Its inverse, right? Now, the inverse of this will be the same as what now? Also f of this, right? Where you are having what? Remember, we just discussed this, that this will be cube root of x, right? Or rather x, the root of x, right? This will be a root of x. And also this will also have the condition where x is what? Where x is greater than 0. Okay. Now, these two now will be understood as a function, right? And what do I mean when I say that? Let's say now I wanted to draw now these functions, right? Let me just draw them in here, right? Let me just draw them in here so that I show you in terms of what will then this be if this was where x is greater than 0, right? Now, for an example now, for the original function, remember the original function, it is made of two parts, right? It is made of this particular part of the graph and then this particular part of the graph, right? Okay, right? But now when x is greater than 0, now when x is greater than 0, we consider the part that is in the first quadrant, right? So which means when x is greater than 0, which means this particular graph, what? We are not going to consider this part. Oh, fine, right? So which means this particular portion, this is the portion of what? Of where x is greater than or equals to 0, right? And now, even in our inverse function, remember we said the inverse function was like this, right? Now we are no longer going to draw these both parts, right? But now we are also going to consider this part here that is going to be in our first quadrant. And what was this graph, right? If you can look at it here, can you see that it was this one, right? So which means even this one here will be what? Will be something that will be like this. Are you together, right? So which means now the inverse function of this now, if let's say I draw my dotted line that represents the inverse, it will look something like this. Are we together, right? And now, right, if I want to draw, and now if I want to then draw, then now let's say I am given that now I am looking where f of x, right, where I am having my f of x is equals to x squared, where now x is lesser or equals to 0, or also where your first, or where your inverse function here will be what? Which is equals to root of x will be same as what? X is less or equals to 0. Now, what is it that we are going to do now from here? Now, can you see that now? The part which won't, the part now of this particular graph that will represent this particular function will be which part, right? Let me just erase here now. So which means now it will be this part where x is less than 0. Now, for the original function, remember the original function was also given by two parts, right? It was given by this part. Now, which means this will be this part over here. And the inverse of it, right? The inverse of it, now, it will be what? The inverse of it, it will be this part that was over here. Again, now these will be the functions that we are having. Again, now this will be the function that we are having, which means now it is important to note that for your inverse of your parabola, right, you need to have the restriction, especially for what? Especially for the inverse of that particular parabola function, for it to be what? For it to be a function, right? Because even if, like, let's say here I had to draw my line graph, now this will be something like this, right? If I had to draw my inverse line, which is y is equals to x. Okay, so now these are the very basic things that I wanted us to know when it comes to the inverse that involves our parabola, right? Maybe now let's just get one question and see in terms of how do we then solve these types of questions whenever we are given, right? Let me just make up my space in here. Now, can you see that here you are given that you are having f of x is equals to x squared, right? Now, can you see that here they want us to find out what is our inverse, right? So, can you see that now that here you're having y is equals to x squared, right? And now, how can you find the inverse? Remember, I said for inverse, firstly, you start by interchanging your y and also your x, right? So, which means this will be same as x is equals to your y squared, right? And then now, what else then now are you going to do now from here? Can you see that now you are going to find the square root here, right? So, which means your y now in this case is going to be same as root of x. Are you fine? Now, let's see something else then now from here, which means now this will be what your this will be your this would be what? This would be our inverse function, which is going to be given by what? By root of x. Now, secondly, now they want us to what? Now they want us to draw the inverse of this particular function, right? Remember, just now to just draw this, right? How are we then going to draw this one? I think by now we have an understanding from our previous video, right? Can you see that this now will be something like this, right? And remember the inverse of a function of x squared. Now it is going to be a function that will look something like this, right? This is going to be a function that will look something like this, right? Let me just draw something like this. And also this will be something like this, right? Altogether, this is going to be the root of x, right? Root of x will look uh, like this one, right? Now they are saying this is, now we've drawn this particular function, right? Now, they want us to explain why is this not going to be a function, right? So now, if I may ask to you, right? If I may ask to you whether is this going to be a function or not, what will be your response, right? Now, remember, this won't be a function, right? They say explain why this will not be a function, right? Because now if let's say we had to draw our vertical test line here anywhere here, right? Can you see that now for each and every x value, right, you're having two y values. Are we together, right? So why will this not be a function? Because this doesn't satisfy the what? The vertical test line. A vertical test line, right? Or this particular graph doesn't necessarily comply to our vertical test line test. But again, so that will be the reason then now that this won't be a function, right? Now they are saying now explain how you will restrict this the domain of f of x to ensure that this will also be a function, right? So now which restrictions that we can do to ensure this now will be our function? What is it then that we can do from here? So which means now from here we are going to say this is going to be where we are having f of x. Now remember this was x squared, right? So the restriction that we may probably write here to make this to be a function, we can say this is where you're having x is greater or equals to 0. Are we together, right? Now, or you can make this where x is less or equals to 0. Are we together? Even this that particular restriction will be correct then to make also our inverse function to be what? To be a function. Are we together? Which means this will be what? This will be our what? This will be our function. Oh, it's okay, right? So I am hoping that this just basic understanding of this particular function makes sense to you now. And as we proceed to some of the videos, you will have an understanding of what is now our parabolic inverse function, right? Thank you very much.